Maniscalco, welcome to newest practical science lessons. Today we'll investigate current. We will inquire why we're using specific equipment to gather data for our experiment. We will analyze the data that we collect during the experiment and we will draw conclusion from those data. So, what do we have here? We have a series circuit, only one loop. We have cells connected in series and we have current flowing through the metal wires into our light bulb and through a piece of equipment called ammeter. Now, based on what I just said, you should be able to say what the ammeter measures. Now, you have to be careful though. The units that the ammeter measures are amps or amperes, but the quantity that the ammeter measures is not amps or amperes, is actually current. That might comes handy in your worksheet. Okay, the first setup that we have is just one loop with one bulb. So we'll go and take our first measurement with this setup. Okay, I'm gonna read from the ammeter. It's not flicking, so we are good to go. It's stabilized to 0.06 amps. So I will write it down in our first circuit here. Okay, here we have a circuit diagram that is very similar to the circuit that we have on the table. The only difference is the switch. We don't actually have a switch, but we don't really need it for this experiment. However, we will not have it in the following circuits as well, so that we can have consistency and we can have a fair test. So as you can see here, we have the ammeter, which is the piece of equipment that just used to measure current, the bulb, and my battery, which is made of several cells. So I'm going to go and write down the first reading with just one bulb, which was 0.06. What are the units? Amps. I need to always include units in my measurements. Okay? Now we'll move to a different circuit, which will look like this. So I'll show you the diagram first, and then I will show you how it is in real life. Okay, the second circuit that I will look at is similar to the first circuit in terms that it's the same type of circuit, it's a series circuit, it's one loop as well. But in this case, I'm going to add one more bulb, so I will have two bulbs, and I will also have 3 ammeters. So I will measure current through this first ammeter, which I'll call A1, current through this other ammeter, which I will call A2, and the current through this ammeter, which I will call A3. The first ammeter is before the first bulb, the second ammeter is in between the bulbs, and the third ammeter is after both bulbs. What I want to understand is if there is a difference in the readings between A1, A2 and A3. Okay. As you can see on the table, there is a circuit that is slightly different from the one before, but is the same as the one shown in the diagram as labeled as circuit 2. The only difference is that we are still missing the switch, but we said that we don't really need it because actually we can just keep the current flowing through this circuit. So I positioned ammeter number 1 here. I've got my bulb, ammeter number 2, my other bulb, which I added to the circuit, and then ammeter number 3, which is after the 2 bulbs. Okay, let's see and check what are the readings in these ammeters. So A1 is 0.04, A2 is 0.04, A3 it's oh, it's flickering a bit, so I need to wait until it's actually getting to the right, only one digit, rather than keep flicking. Okay, I'm noticing that actually keeps flickering, so I'm just taking this opportunity to talk to you about how we would deal with this problem. Well, normally we would take repeats so that we can reduce our random error that will be the result of not having a stable value for our reading. Okay, so in this case we will just take as a value 0.05. Okay, it looks like the most stable out of the two, but good practice will be repeating the measurement and taking an average. We'll go and collect my data and write them down next to the circuit number 2 diagram. So A1 was 0.04 amps. Remember the units. A2 0.04 amps, and A3 we said that it was 0.05 amps. Okay, so look at these numbers here and think about what do they mean, because we need to draw some conclusion from these numbers. Okay, are they really different, or are they very close to each other? I mean, two of them are actually the same. The other one, yes, it's different, but it's not that different compared to the other two measurements. So I'll let you think about that. Okay, we've seen these two circuits, which were series circuits. Now we will move on to a different type of circuits. I will have the two pages next to each other so you can see the difference. Okay, as you can see here, circuit 3 is a different type of circuit. It's called parallel circuit, and I have more than one loop. This is my first loop, and this is my second loop. So I have more than one loop. Okay, that's my one loop and another loop here. So I'm going to create this circuit on the table, and I will take some measurements using different ammeters again. This time we'll have an ammeter here, which is going to be called A1, an ammeter here, which is going to be called A4, an ammeter here in the first branch or first loop, which is going to be called A2, and then another ammeter here in the other loop, which is called A3. So two bulbs, same as this circuit here, but this time we'll put them in parallel rather than in series. Okay, here we have our circuit set up for you. As we said, this is circuit number 3, and it will be a circuit in parallel where we have two bulbs in parallel, and then we have various ammeter in the circuits measuring current at different points in the circuits. So what we're going to do, we're going to actually go and check our readings in the ammeters, and then we will record them and then try to make sense out of them. Okay, so this ammeter here, which was ammeter number 1, is recording, it's flicking a bit, but I think the most stable number is 0.12, again 0.12 amps. Then the first branch, so the first loop, when I look at, is the one linked to this bulb here, and this is reading 0.08. Then the second loop is this one here, connected to this bulb, and is reading 0.04 amps. Now we're going back to the other side of the circuit. Why did I say going back? Well, because in a way the current flows through this ammeter first, then when it gets to this point here, it kind of splits up. And then some electrons will carry energy in one branch, and some other electrons will carry energy in the other branch. So when we go back to this place here, where I put my ammeter number 4, the electrons join back together. So I can measure how many charges per second pass by here, which is the current. And in this case, we have, again, 0.12. Oh, wait a minute, this is the same value that we had at the beginning. Okay, so this might tell us something. Okay, I'm going to go and write down the values in your result sheet so that we can make sense out of these numbers. Okay, so A1, we said that was this one here where we started, and it was 0.12 amps. A2 was the first branch, and it was 0.8. amps. Then A3 was 0.04 amps. And A4 was again 0.12 amps. Okay, so let's look at these numbers. What do you notice? First of all, A1 and A4 are actually measuring the same value for current. As I explained, the electrons will carry energy around the circuit, and when they get to a certain point where they can take two different routes, will split and will carry energy in the first loop and in the second loop. But afterwards, they will rejoin and they'll be all back together, and that's the reason why we have the same values here. There is another thing that I wanted to realize from this data, but I'm not going to actually reveal it because I want you to figure it out. But look at A3 plus A2 and think about what is the result of that and how compares to these two values here for A1 and A4. Now, if we had two bulbs with the same resistance, these two values should have been the same. However, it looks like that in our circuit, these two bulbs have a slightly different resistance. Another question I can ask you is, which one do you think has the highest resistance depending on the amount of current that can go through? Think about that. Okay. So, what we've seen today are different kind of circuits, two series circuits and one parallel circuit. We changed the number of bulbs that we use for the series circuits, and we changed the arrangement of the circuits for two bulbs. One was in series, one was in parallel. And then we took some measurement of the current flowing through different parts of the circuits using an ammeter. We figure out something that might make up a rule. So what I want you to do in your worksheet is actually drawing conclusion from the numbers that we measured today. Hope you enjoyed the practical. I'm Dr Maniscalco. This was Nuet's practical science lesson. See you next time.